All right, today we're going to build an idea from the ground up. I mean, an idea that is completely reshaping finance, technology, and, well, our very concept of trust. We are going to tell the story of blockchain.
Think of this whole explainer like a book, a dynamic one with 5 really distinct chapters. We're going to start with the fundamental problem that kind of set the stage, then we'll introduce the hero of our story, explore the challenges it faced, see how it was built piece by piece, and finally, discover why it's become this, digital fortress.
Okay, let's just dive right in. Every great story starts with a conflict, right? A fundamental problem. And for blockchain, that problem really starts with 2 very, very different ways of looking at the world.
So on the left, you've got a centralized system, a structure you deal with every single day. And on the right, you have a decentralized one. And trust me, the huge difference between these 2 diagrams, that's the entire reason blockchain was even invented.
Just think about it for a second. Your bank, your social media, your email, they're all centralized. There's one company, one server, one single authority that's in charge of all the rules, all the data, and basically keeping the lights on. Sure, it's simple, it's efficient, but it's hiding a really critical flaw.
And this slide right here shows exactly what happens when that central point of trust gets broken. If that one single hub goes down, I don't care if it's a technical glitch or some kind of targeted attack, the entire network goes with it. Poof! Everyone's disconnected. It's what we call a single point of failure.
But what if there was another way? A system with no center, no single ruler. In a decentralized network, every participant, every peer is equal. So if one of them goes offline, the network barely even notices. It just keeps on running. It's not just resilient, it's what you'd call anti-fragile.
Now, this powerful idea of a leaderless, super resilient network didn't stay a theory for very long. Back in 2008, right in the middle of a global financial crisis, it became the opening line of a totally radical new chapter for money.
The goal, laid out right here, was nothing short of revolutionary. I mean, what if we could create digital money that didn't need a bank? Money that could just move between 2 people anywhere on Earth, with absolutely no middleman taking a cut or telling you yes or no.
So this vision was published in a white paper by this mysterious figure known only as Satoshi Nakamoto. And get this, to this day, nobody knows who they are. But this one anonymous paper laid out the entire blueprint for Bitcoin, and with it, the whole field of blockchain technology. Okay, so this is the crucial point. Bitcoin isn't some digital file you keep on your computer. It's really just an entry in a massive, shared, public record, a ledger. Think of it like a global storybook of every transaction, and a copy is held by everyone in the network, all at the same time.
Right. But trying to write a global storybook with millions of authors and no editor-in-chief, well, that creates some pretty fascinating plot twists. In this next chapter, we hit the core challenge. How do you get everyone to agree on the story when absolutely no one is in charge?
I mean, really think about it. You've got people making transactions all over the globe. Messages are going to arrive at different times for different people. Without some central clock to timestamp everything, how could the network possibly agree on what happened first? It would be total chaos.
The solution is just incredibly elegant. Instead of arguing over the order of every single little transaction, the network agrees to just bundle them up. Transactions happening around the same time are all grouped into a block. Think of it as a single page in our storybook, for everyone to approve all at once.
So that solves the timing problem, but it introduces a brand new villain into our story. If approval is based on a vote, what stops one single bad actor from creating thousands of fake identities to just hijack the vote and write their own fraudulent pages into our book? That's called a Sybil attack.
So, how does our decentralized network beat this villain? Well, it uses this ingenious mechanism that makes cheating insanely expensive and makes being honest the most profitable thing to do. And that brings us to the chapter on how the chain is actually forged. It's called proof of work. To earn the right to add the next page to the story, you can't just show up. You have to prove you've spent real-world energy by solving an incredibly difficult mathematical puzzle. It's like a ticket to vote that you can't buy or fake. You have to literally earn it with raw computing power.
The whole process unfolds like a ritual. First, these participants we call miners gather up all the pending transactions into a new page, a new block. Then they all race to solve that puzzle. The winner gets to broadcast their new verified page to the whole network. And, this is crucial,
They link their new page to the previous one using a kind of cryptographic seal.
And that right there brilliantly shows you where the name comes from. It is, quite literally, a chain of blocks, with each one cryptographically bound to the last one, creating this continuous, ever-growing history.
Okay, but what if two miners solve the puzzle at the exact same time, creating two competing versions of the next page? The network has a really simple but powerful rule to sort this out. The longest chain wins. Everybody just agrees to abandon the shorter version and keep building on the one that grows the fastest. It's basically survival of the fittest for truth.
Okay, let's move into our final chapter. We've seen how the chain is built, how it reaches agreement. So now, let's see how all these pieces combine to create something pretty extraordinary, a tamper-proof digital fortress.
The security all hinges on cryptography. Every single block has a unique digital fingerprint, which we call a hash. And as you can see here, if you change even a single character inside that block, like changing 1 Bitcoin to 100, the entire fingerprint changes completely. It's totally unpredictable.
And remember, each block contains the fingerprint of the one right before it. So if you try to go back and alter a past page in our storybook, you change its fingerprint. Well, that breaks the cryptographic seal to the next page, which then breaks the seal to the page after that, and on and on and on. A single change creates this catastrophic domino effect, and it invalidates the entire rest of the chain.
So to successfully rewrite history, an attacker would have to secretly alter a block, then resolve the super difficult proof of work puzzle for that block, and for every single block that came after it, all while doing it faster than the entire honest network combined. To even have a chance, they'd need to control more than half of the network's total computing power. That's a 51% attack.
So what you have is this elegant combination of cryptography, peer-to-peer consensus, and economic incentives that creates a system where the truth is protected by pure mathematics and the collective power of the network. The story of blockchain is really a new story about trust, and the question it leaves us with is, what other parts of our centralized world are ready for a brand new chapter?